All right, good morning, you guys. Have to go through a couple of homework problems here. People asked about these. So what I've done is I've put them in order from green, blue, black. We'll just go right through them in order as people ask them. If you take a look at the green problems, there was a couple questions about number 1, 2, and 3, which really are just straightforward multiplication. Okay, I've got weight of meat times price per kg in number 1. I've got weight of capsicums times price per kg in number 2. And I've got cost of chocolate bars times the number of chocolate bars. And each one of these is simply the price times the amount will give me the total that I'm looking at. All right, so I'm only going to work one of them out because they're all exactly the same, including how do you round and answer sensibly with money. All right. So one of the first things to keep in mind is that you always work a problem all the way through before you do any rounding whatsoever. So I'm going to go to a blank page here and I'm going to do the first problem where I've got to multiply the price of the meat times the amount of the meat. So I've got 1.455 kg times 7.99 a kg. And then it's just straightforward multiplication, right? I forget about the decimal points. I line up numbers to the right, and I just multiply. 5 times 9 is 45, carry the 4. 5 times 9 is another 45, plus 4 is 49, carry the other 4. 4 times 9 is 36, plus 4 is 40, carry the 4. 1 times 9 is 9 plus 4. Then I'll just go through and I'll do the rest of the multiplication, right? The next line, the numbers are going to be the same. Next line, I add zeros at the end of each one, and then I just multiply the whole thing times 7. And it's a straightforward multiplication problem. Okay, line them up, multiply them down, and then I'm going to just add each column. And when I do that, I get this big, hairy number that looks a little bit weird for a price. Yeah, I ended up getting 11,62545. Okay, now I need to add up how many numbers were behind the decimal point in my original problem, right? So I got 1, 2, 3, 4, 5 numbers behind the decimal point. So I have to have 5 numbers behind the decimal point in the second part of the problem. 1, 2, 3, 4, 5. So I'll end up with this number 11.62545. Now, I would not write $11.62545. Money is always rounded to the hundredths place. So I look at the hundredths place, and realistically, guys, with money, it's always rounded up. Okay, even if that number was not a 5, I would still round my cost up. So this is going to be $11.63. All right, with money, that's always the way things are going to work out. And so basically, for number 2 and 3, it's the very same thing. The only trick on number 3 is when it says 95 cents. 95 cents I would have to write as a decimal. And how would I write 95 cents as a decimal? That's right, 0.95. Okay, so you multiply them out, you get your answer, you put it to the next hundredth, and that's how you deal with costs and money in dollars. Okay, let's move on to the next problem now and see what we get. All right, the next one people asked about was number 7. Okay, to hire a car costs $57 a day plus 37 cents per kilometer traveled. All right, and it's the very same thing as you were doing before, except now you've got two amounts that you're looking at: $57 per day and 37 cents per kilometer. So you have to multiply the cents times kilometers and the dollars times days. All right, remember, we'll just erase from our previous problem here. Remember that when you're talking about cents, 37 cents is going to be 0.37. Okay, so you multiply that times the number of kilometers. You multiply $57 times 8 days, that's $456. And then you add the two amounts together. All right, I'm busy erasing all the work from the previous problem here. I got to figure it out. 37 times 1452. Great, I can do that. 37 though, remember, 0.37. And then when I multiply that out, 1452 kilometers times 0.37. That'll give me some number, blah, 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 blah. I'll add that to $456. I'll make sure that it's to the hundredths place because money is only to the hundredth place, and that will give me my total cost. Okay? Good. All right. Next question that people asked about was looking at which one? Oh, number 18, the field trip, the school minibuses. All right. This is the same sort of idea again, except this time instead of having whole numbers that I'm multiplying things by, this time now I've got decimals again that I'm going to be multiplying by. All right. It's the very same type of question. So I just multiply 10.4 liters times 95 cents per liter. Maintenance costs 45 cents per kilometer times 183 kilometers. Multiply them together and I get a cost for each of them, and then I get a total by adding them together, right? So I have to do the gas and the maintenance. 10.4 liters of gas times 195 cents per liter. That gives me my gas cost, my maintenance cost, 45 cents per kilometer times 183 kilometers. That gives me the maintenance cost. Add them together, and I am good to go with that. Okay, so it's the same as the problem right before. The other one that people asked about was number 17. And number 17 was a little bit of a thought tricker, different problem, because actually it didn't even involve multiplication. It involves just kind of picturing what's going on in the situation. So you got two sets of people, right? You got Jim and Irene, and they're a certain height. They're 2.98 meters. So here's Jim and Irene stacked on top of each other, right? They're 2.98 meters. And then I've got Irene again and Mark this time. But when I stack them on top of each other, they're a little bit shorter, 2.94. Now, Irene's height's the same in both of them, yeah? She's this tall. So the trick to looking at this problem is the only difference in height is how much taller Jim is than Mark, right? The Irene doesn't even matter how much taller Mark is than Irene. It doesn't ask you to find the real measures of them. So you just got to look at the fact that Jim is going to be 0.04 of a meter higher than Mark. 4/100ths of a meter. Just subtract them. It was a thought problem. Didn't involve multiplication. It was a little bit of a trickster. All right. Question that was asked about the blue level ones was, how do I take a number that's written in standard form and put it into scientific notation? Okay, and blues and blacks had lots of these to do. So 160,000 equals 1.6 times 10 to what power? Okay, because scientific notation always has the first factor as a number between 1 and 10. So really, what I've got to figure out is how many decimal points difference are there between these two numbers? Okay, and so I look at, all right, how would I have to move the decimal point from here, which is where it is in 160,000, to get it to be 1.6? And I'd have to move it 1, 2, 3, 4, 5, 6 places. Or I'm sorry, 1, 2, 3, 4, 5 places. I miscounted my numbers there, right? So every time I move the decimal point, I'm moving it a power of 10. That's 5 places over, and that's just the number that's in the exponent, okay? Now, there's another question asked going the other direction, right? How do I turn a number from scientific notation into standard form? And it's just the opposite piece, right? Here, I'm starting off with numbers that are already in scientific notation, and I got to figure out what happens if I multiply them by 10, in the first case, number 7, 10 to the 7th power, which really is just the same thing as moving the decimal point 7 places. All right, so I start off with 3.21, and then I'm just going to move 1, 2, 3, 4, 5, 6, 7 places. And every time I multiply by that power of 10, I'm moving the decimal, or if I don't have any placeholders there, I need to put in zeros as placeholders. Okay, so my decimal point ends up way out there. I put in my zeros as placeholders, and then I rewrite the number just putting in proper commas as needed. Okay, So I've got that, and I count 1, 2, 3 thousands, 1, 2, 3 millions, and I've got 32,100,000. All right, same thing with number 9. I've got 1.006 times 10 to the 10th. All I'm going to do is take that decimal point and move it 10 places to the right. So I get my red pen and I mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in each place that doesn't have a number, I need to put a 0 placeholder in. And once I've got that in, I just rewrite it. Careful to have the same number of zeros and the same number of digits, and then throwing in my commas. Comma 1, 2, 3, 1, 2, 3, 1, 2, 3, and what I end up with 10,060,000,000. And that's how you turn numbers from scientific notation into standard form. Thanks.